Hi, this is the Professor D, and we are back to part two of the nursing basic drug dosage calculation. And I try to make it as simple as possible for you to understand and hopefully find it helpful. Okay, so in this part two, these are the topics we are going to cover: calculating intake, military time, calculating IV drip rates, also known as flow rates. There are two kinds. We have either drops per minute or we have to find milliliters per hour. We'll also be calculating the run time, which is basically the time that it will take for our IV fluids to run or to finish. So that's a run time. So that is recorded in hours. And lastly, we will be calculating completion time using military time. So let's get into the fun. So the first thing we are going to talk about is the calculation of intake. So when we talk about intake, our patients are going to be consuming a lot fluids. They are going to receive blood transfusions. They are going to be drinking. They are going to be receiving feedings through tubing. And so all of these things, as our patients are consuming, we have to take record of everything that they are taking in. So what we factor into calculating intake is all the fluids that they take in. It can be a cup of coffee, it can be gelatin that can melt under room temperature into liquid. It can be broth, not chicken broth, because the chicken is solid in there, so that won't be counted. Um, and like I mentioned also before, they get IV fluids, all of that is factored. Blood transfusions, all of that is factored. Okay, and it's the same way if we are to calculate their output is basically every fluid that can be measured and it comes out of them. So, such as bowel movement in form of diarrhea, we can measure, right? Vomit will be an output to factor, and so um, oftentimes you will be given scenarios and you will be told what patient consumed and what you need to um, calculate into the intake record for that patient. Now, there is an important rule when it comes to factoring ice chips. All right. Now, on this slide, as you can see, I have a picture of ice cubes. Now, the ice cubes tend to take up space when within the picture. So what happens is once that all that ice cube melts, you notice that the volume or the measurement is going to reduce. So the rule when it comes to factoring ice chips is if you are given, for example, if you are told patient consume 500 ml of ice, take half of that measurement into your intake calculation. You don't take the full 500 because once the cubes melt, it's gonna be half of what was given. All right. Another quick way for you to remember what to factor into your intake calculation is to look at the units of the items that you are given. So, for example, if you are told a patient consumed a cup of coffee, a cup can be converted to ml, and so that should, that kind of cues you into knowing, okay, I need to convert the cup into ml so I can factor it into the intake calculation. Same thing, you may be given teaspoon, tablespoon of feeding, of medication, all of that. So long as you can convert that unit into ml is another great way of you remembering what you can include in your intake record when you have to calculate everything at the end of the day. The first activity I have for you is an old nursery rhyme once again, and from that we do have an activity. Let me see if you can pick it up. Now, this nursery rhymes goes like this. Betty bought a bit of butter, but the butter was bitter, so she bought a better butter to make the bitter butter better. Now, if each butter measured 4 ounces, how much total butter in ml will she record on the intake record sheet? Now, note how many ounces, how many times does she have to purchase butter, and how many ounces does each butter hold. In the problem, it says each butter measures 4 ounces. Now, we can take 4 ounces and record on the intake record. We need to convert that to ml. So this requires us to know what is 1 ml equivalent to ounce. So we know 1 ounce is equivalent to 30 ml. So if we narrow down to the fact that Betty had 8 ounces of butter, all we then do is multiply 8 by 30. And so our answer that we will record on the intake record sheet is 240 ml. On this slide, I have a list of items for you to convert for Betty, so we can calculate everything that she consumed on the intake record. So I gave you a little tip over here. I said if 1 ounce is equivalent to 30 ml and 1 cup is equivalent to 8 ounce and 8 ounce is equivalent to 240 ml, tell me what then is 4 ounce of clear soda converted to ml? You should get 120. Half a cup of chicken broth she consumed is equivalent to 120 ml. Now 12 ounces of water is equivalent to 360. Why? Because 1 ounce is what? 30 ml. 1 cup of fruit flavored gelatin. Now remember, gelatin, if you place under room temperature, is going to melt into liquid, and a cup is measurable and can be converted to ml. So here we have 240 ml. Now she also was given 300 ml of normal saline. So now the 300 ml here is already given to us, and so we just plug it in. All right, it's given. Just take it and bring it to the other end of the record. Now, she also consumed 2 plates of 2 pounds of rice and roni. Now, can this be calculated? It's all solid. Can we change it into ml? No, this is pounds. So we are not going to factor that into her intake record. She also had 3 tablespoons of IV contrast for colonoscopy. Okay, 3 tablespoons. If you remember from the first part, what is 1 tablespoon equivalent to in ml? I believe that was 15. So 15 times 3 is 45. And then teaspoon. She had 3 teaspoons of, antibiotic medication. So again, 1 teaspoon is 5 ml. So 3 of that will be 15 in total. And then all you have to do now is sit back and just add up everything. So this is straight up addition. All right. Now, one important advice I give to everyone is that when you have to add up a lot of numbers like this, go back into the question. Make sure you tick off all the items that you are needing to factor into your calculation. Just go over them once more to make sure you have gotten all the numbers before you do the calculation. Once you do the calculation, I advise just check it one more time to make sure that you got the same answer. If you got a different answer, if you have 2 different numbers on one same problem, there's a chance that one answer is correct and the other is wrong. I would say do it, check it again for the 3rd time to make sure that you get the same answer twice. All right. Now, some students do have a tendency of adding up all the ounces in their intake item before, to do their calculation. That's not a bad approach. You just have to pay crucial attention to convert the total ounces at the end of your math. Convert it to ml because the answer must be recorded in ml. What they sometimes forget to do is to convert that total ounce to ml, and then they get the answer wrong. So sometimes they do know how to, what they are doing, but they just forget that conversion, and it kind of makes them fail. All right. In the slide, we are going to talk about military time. Now, wherever you are, I want you to pull up a chart or that shows military time versus real time. You are going to need to examine these numbers so closely. You need to know the differences between them and how they are written. All right. You need to know which one uses semicolon and which one doesn't use semicolon. All right. Practice writing examples of each. Like I have put in this slide, 12 a.m. is equivalent to 0000, not 2400 in military time. 11 p.m. is 2300. 4 p.m. is what? 1600. 5 p.m. is what? 1700. Okay? So please make sure do this review constantly if you're not familiar with military time, so you will get it right. You should not be getting mistakes on how to write military time. And again, it takes more and more practice. More and more practice, they say, makes man perfect. All right, we are beginning to get a bit complex, but we will get through. Don't worry. Now, this is another military time kind of question. All right, a bag of IV fluid started for a patient at 0830. As you can see, it's written in military time at a rate of 120 ml per hour by 10 a.m. But in military time, as written in the slide, 1000, it looked like 1,000. Now, how much fluid would have been infused? Notice that you have a starting time and you have an ending time. All right. So at 0830, we just started to run this IV fluid at 120 ml every hour. Now, when you get a question like this, remember at the start, it's like you pressing a button that says start the infusion. Now, when you push that button at that start time, notice that nothing has infused until a whole hour has gone by for the patient to get that whole hour rate that is indicated. Many people have the tendency of attributing the hourly rate right next to the starting time. And if you do that, you set yourself up for getting that question wrong right away. So let's look on the left side here. What do I have? At the starting time, there is zero infusion. That's at 0830. After one whole hour, according to the problem, we have 120 ml infused. That 1 hour led us to 0930. Now remember, the ending time is 10. Okay, so if the ending time is 10, between 0930 and 10 is only 30-minute interval. Therefore, we only have 30 more minutes to get to the completion time. Therefore, only half of the hourly rate also can be expected to infuse. What some students tend to do here is they forget and they attribute another whole hourly rate to the 10. And then what happens is they end up getting the question wrong. All right. So that's why I said these nursery rhymes make you pay very close attention to every detail, every moment, what you are doing, because drug calculation can be very, it is very serious. Slight mistake can make you give the wrong dose, which is not good for the patient. And that's what we are trying to prevent here. So let's solve the problem. Starting time, 0 infused, 1 hour, give 120, then half of the hour, give only half of the hourly rate of 60, so our answer here is 180 ml. Now, some students also have the tendency of wanting to deduct the completion time from the starting time and then multiply by the hourly infusion rate. It's not a bad approach. However, that approach do not work well when the times are now written in whole numbers. I mean, if they are not like even. Okay, so in this case we have a 0830. If this was 090, it will make it easier for you to do the calculation. If it was 0800 even, it's easy to deduct that from 10, and we know we have exactly 2 hours, and then we'll multiply that by 120. But when you have, this 0830, the time ending in minutes, like 45 minutes, 25 minutes, it makes this kind of approach dangerous to take. All right, make it simple for yourself. Start with the starting time with 0 infusion, and then take every hour from them, paying close attention to the ending time so you can make any adjustment to the infusion rate as needed. On this slide, we're going to talk about calculating IV drip rates. Okay, you'll be asked to find flow rate, which can be either to find the drops per minute at which the IV fluid is going to be infusing through a special tubing set to the patient. Okay, so that can be worded as flow rate or the drip rate. It's important to pay attention to the unit that is being requested. So if it's drops per minute, you will see GTT per minute, or they may say drips per a drip rate. It's the same thing. If the unit in the question is drops per minute, which is GTT per minute, the formula is going to be the same. So don't get confused with whether they say drip rate or flow rate. Always pay attention to what information do I have in the question, what unit am I solving for. When it comes to calculating drop rate or drip rate in terms of drops per minute, GTT per minute, you will always be given the volume of the fluid that you need to factor into your calculation. You will also be given an important number called a drop factor, often written as GTT per ml or drops per ml. Okay, is always given. If that's what you must solve, you will have it in the question, so do not worry. Now the drop factors can be, they can have different numbers. It can be written as 10 drops per ml, 15 drops per ml, that's the 10 GTT per ml, 15 GTT per ml, 20, 30, it can go as high as 60. Now, the problem with the 60 drops per ml is that sometimes they would say that the nurse is using a micro drip set. So if they say that the nurse is using a micro drip set, they may not necessarily tell you is 60 drops per minute. You are expected to know from your knowledge of drug dosage calculation that a micro drip set always delivers a drop factor of 60 GTT per ml or drops per minute, and that information you will need to factor into your problem. Now again, GTT per ml simply means drops per milliliter, drops for each milliliter. Okay, now what is the formula to solve this problem? Like I said, you will have to find the volume, identify the volume in the problem. You will be given the drop factor to work with, so identify that in the problem. And then you will also be given the time to work with. All right, in this problem, if you are going to find drops per minute, look for the time given to you in minutes. It doesn't always come, that perfectly. Sometimes we are given the time in hours. If you are given the time in hours, it's okay. Just remember, if I'm to find the flow rate with a unit of drops per minute in the presence of a drop factor, I must have my time in total minutes to work with. So let's see an example. Calculate the IV flow rate for 1 liter of normal saline in 8 hours with a drop factor of 15 drops per ml. Again, let's identify the volume. The volume here is 1 liter, but we have to convert 1 liter to ml, so that will make it 1000 ml. According to the formula, multiply that by the drop factor. The drop factor here given to us is 15 drops per ml. Life is easy. Multiply your volume by the drop factor, and then whatever the answer is, divide it all by your total time in minutes. All right, so you might get an answer like this: 31.25 drops per minute. Now when you get your answer, always go back to the question and find out, are they asking you to round or not to round? If you are asked to round, then go ahead and round, and they will tell you what should you round to the nearest whole number, the nearest 10, the nearest hundreds. That should be made clear. If not, leave it alone. Based on my experience, you are given, you are told whether to round or not to round, and to what place value you should round to. So always go back and look at the end of your question what you should do with the answer before you click that submit button. Okay? All right, let's look at another challenge. The doctor has ordered 1200 ml of saline to infuse over 360 minutes. You are using a micro drip tubing set. Calculate how many drops per minute this infusion will be running. All right, so remember what a micro drip tubing set delivers. If you don't remember, just flick to the last slide. It tells you 60 drops per minute, 60 drops per ml. And so with that in mind, now we are going to plug in the formula and solve our problem. What do we need to satisfy the formula? We need the volume in ml. In this case, it's already given to us. That's a 1200 ml. And then the beautiful thing is they also gave us the time already in minutes. So we don't need to convert anything. All right. So go ahead, plug in the, satisfy the formula by plugging in the numbers. 1200 ml multiplied by your drop factor, in this case must be 60, and then divide by the total time in minutes, and there goes your answer, 200 drops per minute. And always make sure bring the units that is being requested. If it's drops per minute, you must bring it next to the answer, otherwise They can read your mind and they will give you wrong. Okay? Going once, twice. Okay, so this is the second type of flow rate you will be asked to calculate. In this flow rate, you are being asked to run the infusion on an hourly basis. So this requires us to set up the pump to run the IV fluid every hour to deliver the volume every hour. So in this case, we're not dealing with drops per minute, we're not dealing with drop factor, we're not dealing with no special calibrated tubing set. Okay, so this is straightforward. Um, and in this, again, the language may sound very similar. They will request find the flow rate or the drip rate. Again, pay attention to what information are you given to work with in the problem, and what unit are they asking you to find. If it's ml per hour, you're not worried about any drop factors, so don't look for them. Make your life simple and move on. All you have to do is find the formula that you're going to use. If you are looking for flow rate, which is ml per hour, identify once again the volume always given in the problem, divide by the time again given to you in the problem. If you are to find the rate of ml per hour, the time will be given to you in the problem, and just go straight ahead, divide those two numbers, and there goes your flow rate. So let's look at an example, okay, of an activity. Calculate the IV flow rate for 1 liter of normal saline in 8 hours. What does this mean? This is only asking that if you have a liter bag of normal saline is IV fluid we run into the patient. If you have this bag of fluid, and this bag of fluid must finish by the 8th hour or within 8 hours, how much are we going to set up for the pump to run this fluid in order to finish by within 8 hours? So that's all it's saying. All we do, take the volume, the total volume, divide by the total number of hours you are given, and that's it. In this case, 1 liter, again, don't forget, convert to ml. So 1000 divided by 8 hours, you have 125 ml per hour. That's it. So which means every hour the patient is receiving 125 ml of fluid. Now let's look at this problem. This gets a bit I don't want to say complex, but it looks like it. We don't live in a perfect world, and so sometimes what we expect is not what we get. Now, in this problem, it says the doctor has ordered 1200 ml of saline to infuse over 45 minutes. Calculate the flow rate at which the nurse must set the pump to complete the infusion within 45 minutes. Okay, so here can we identify the information we need to work with based on finding the rate formula. The rate formula, we always are going to need volume from the problem. So can we identify our volume? The volume here is 1200 ml. Okay, fine. What else do we need? We need time. The time here is given to us in 45 minutes. Okay, and we have to find the rate of ml per hour. It does not give us any drop factor. It does not give us any special tubing set. Nothing. So we are not looking at drop factor. We are not looking at drip factor. We are not looking at none of those things. We have our volume. We have our time. We are to find ml per hour. So apply the same principle. Go ahead, plug in the numbers and do your division. So 1200 divided by 45 minutes make us end up with this whole all these numbers with it's like it is a decimal number. All right, it seems like a lot, doesn't seem reasonable. It's okay because it's not complete yet. There's one additional step when you run into problems like this. There's one additional step you have to take. Remember, we have to set the pump to run every hour, and so if we divide by minutes, then it means this is what is going to be running every minute. So to have the hourly version, all we have to do then is to multiply by 60 minutes to get the hourly conversion. And so proceed. 1200 divided by 45 minutes, whatever the answer is, multiplied by 60 conversion, and then you should get your hourly rate of the infusion. Now it looks like a big number. 1600 is a big number, but let's see if it makes sense. That's another thing. Whatever we do, we have to make sure, is it safe? Is it making sense? So long as we are applying the principle in place, we should know that it's okay. All right. So let's see if it makes sense. If you look at the relationship between 1200 and 1600, for example, what I notice is they are multiples of 400 ml for every 15 minutes of time. It may take a while for you to see it that way, but that's what I'm seeing. So I'm throwing it out there. Now let's look at the second line. It said for every 15 minutes, it looks like 400 ml of the solution is infusing. So look at it again. 400 times 3 is 1200, right? 3 times 15 is 45 minutes. So that makes sense with why in 45 minutes we have 1200 of the solution to finish. How about the 1600? 400 times 4 is 1600. 4 times 15 is 60 minutes. That's the hour. So it makes sense that in 45 minutes we can expect the infusion of 1200 to infuse. Since we don't have 1600 to infuse over 1 hour, we have to set the pump, make the pump believe we have 1600 ml so that it can take 1 hour to finish infusing into the patient. Okay? Take some time, go over it in your own time, digest it. Who knows, you may even have a different way of approaching the problem. So long as we both arrive at the same answer, you are good. All right. Now, many of the questions are not this complex, but I always throw this in here to prepare the student, prepare your mind, so when you come across something like this, you can easily knock it off. So when you get the chance, just take your time, go over these some of these examples I have given, and they say practice makes man perfect. All right, so we have calculated the two different types of flow rates. One is ml per hour and the other one is drops per minute. Please learn those formulas to make your life much easy. And you know, find practice questions online. From now on, you can go online and type in drug dosage calculation practice questions. You are going to find so many, and you can now begin to relate and be able to do them. All right. So now let's look at calculating the run time. Remember, we have been calculating the rate, ml per hour, drops per minute. When we had to calculate the rate, we were given the time to factor into solving the problem. So it's the same thing here. When we have to find the run time, we will be given the rate to work with. So it will be given to you in the problem. Same thing, the volume is standard. We are always going to have the volume to work with, but it's up to you to be able to identify which number is the volume to work with in the problem, and which number is going to be the rate for me to work with the problem. If you can't identify those numbers from the problem, I have done well to underline them for you, highlight them for you, to help you kind of begin to, you know, be able to pick them up. Okay, so let's look at this challenge. We have a 56-ounce can of Ensure is ordered to be infused at a rate of 240 ml per hour. So which means every hour this patient is supposed to receive 240 ml of this can of Ensure. Now, how long will the Ensure take to finish infusing? So this is most likely a patient who is receiving the feeding through some sort of tubing. Okay, and so we want to know how long is it going to take for it to finish infusing if every hour he or she is getting 240 ml. Okay, so again, formula, we need the volume. Now this volume is given to you in ounces. Remember the rule, you need your volume to be in ml in order to solve these problems. And so you need to know your conversions very well. What is an ounce equivalent to ml? 1 ounce is 30 ml. Therefore, if I have 56 ounces, just multiply your 56 by your 30 to get the total ml to work with. Once you have that, easily plug in the formula, volume divided by the rate. The rate here in the question is what? 240 ml per hour. Bring it, just as is, written and said. Divide them. And your total time is right here, 7 hours. If you want to double check to make sure, does this make sense? Is this safe? Is this correct? Go ahead and multiply 7 by 240. So which is 7 hours multiplied by the rate at 240, you should arrive at 1680 ml. If you do not, it means you did something wrong along the way. Just go back and double check your steps, all right, to make sure you get them right. So runtime, volume divided by your rate is your runtime. End of story. Going once, twice. Take your time and absorb it yourself. Okay, let's look at another runtime kind of question. So there are times when they don't just ask you for how many hours that the infusion is going to take to run. Sometimes they can also ask you to record your answer in hours and minutes. Regardless, if your answer turns out to be only hours and 0 minutes, so long as you have the 2 dashes to satisfy in the problem, please do so. If it's 3 hours 0 minutes, bring your hours and minutes as is instructed. Otherwise, you will not get the full credit. Okay, now there is a special rule that you need to learn about, because there are times you run into answers with with decimal numbers, and this is one of them. Now let's look at the problem. It says calculate the infusion runtime for 215 ml bag of D5LR solution at a rate of 60 ml per hour. Record your answer in hours and minutes. First, let's identify what is the volume here. Go ahead and circle it. It must be your 215 ml. Now you'll see other numbers like D5LR, 0.9% normal saline. Now there are distractors within these questions, and you need to know how to cancel them out of your mind. All right, they are names of the solutions that we use. They have no units next to them, they have no measurable units next to them, so do not factor them into your problem. Like in this case, D5LR, there's nothing in there that says you can use it, you can factor it into the equation. Okay, it's just the name of the solution. So our volume in this case is 215 ml. What is the rate we are given? The rate we are given, again, is underlined for you, 60 ml per hour. What does the formula say? It says volume divided by my rate will give me my runtime. So go ahead, plug it in. 215 divided by 60, and you should end up with a number that looks like this, 3.58333 da 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 da. Now remember the rounding rules in part 1. Anything before the decimal point is your whole number, right? That's the place value for the whole number. So we have 3 whole hours. And then what happens? This is where many people make mistakes. They take 0.58, or they round the 0.58 and they put that as the minute. This is a fraction of a whole hour. Everything after the decimal point is a fraction of a whole hour. So that's not the actual minute. If it's a fraction of a whole hour, it means we need to solve that fraction of that number, which in bracket I brought over here. Take that number, on your calculator and multiply it by 60 minutes conversion to give you the exact minute out of the hour. Okay, I'll go back again. Go write down the formula. Take your ml from the problem, divide by the rate as you are given in the problem, and you have an answer. That's your infusion time, your run time. If you end up with a decimal number, any number before the decimal number is the whole number place value, that's your whole hours. Anything after the decimal point is only a fraction of a whole hour. A whole hour converted to 60 minutes, so it's easy for you to get that fraction. If you bring 1, if you multiply this by 1, what are you going to get? You're going to end up with the same number. So that wouldn't make sense. Okay, so take the remaining of the decimal number, multiply by the conversion of 1 hour, which is 60 minutes, so you can get the exact minutes of the whole hour. So in this case, our correct answer is 3 hours and 35 minutes. Okay, so see if it makes sense. If you multiply 3 hours by 60, that's 180 ml. 180 ml deducted from 215, and you will see how much you have remaining is a bit more than half of the hourly rate, which is equivalent to 35 minutes. All right, am I right? Let me check it out quickly. So we said 180, 215 minus 180 80. Yeah, you have 35 ml remaining to infuse, which makes sense because we have 35 minutes or a bit more than the hour, more than half of the hourly rate, which makes sense. It's not a whole hour, okay? Because a whole hour, another whole hourly rate will definitely will be more than 215, okay? All right. So in this slide, we are going to talk about calculating completion time. All right. So completion time also have a formula. The formula is find the starting time given to you in the problem, often written in military format. If it's not written in military format, you are expected to write it in military format. Add it to your runtime also in military format, and that's it. It sounds simple, right? Well, not so simple. There are times when we have certain numbers that are greater than 2400. If you find yourself in that situation, just subtract that answer from 2400. Again, if your completion time ends up to be greater than 2400, subtract your answer from 2400 and it will give you the exact finishing time. So let's look at a few examples. The RN started an IV fluid bath for a patient at 0330 at a rate of 120 ml per hour for 5.5 hours. Then another bag started at 0600 over 9 hours. Calculate the completion time for the IV fluid bags A and B. So we have two problems here to address. What is the formula? We say start time in military format plus the run time in military format would give us the completion time. Let's put it to the test. What is the start time given in bag A? It's 0330. What is the run time given? It says 5.5 hours. So now that's our real time speaking. But in military time, it's 5 hours and 30 minutes. And so to write it correctly, we have to write 0530 in order to get the math right. Okay? Not 0550 and not 5.5. It's 0530. That's military format. Military language is 5 hours and 30 minutes. Now let's solve the problem. 0330, plug it into your calculator, plus 0530. What do you get? 0860. Now, have you ever seen a time, even in real time, that says 960 or 1060? So it's the same way. We don't have 0860. We don't have 0360. Now the 60 is a whole hour on its own. So when you run into situations like that, it's okay. Change the 60 into a whole hour and add it to the remaining hours. So in this case, 0860 becomes 0900. Okay? So it means if the infusion started at 0330, by 0900, it will finish infusing. And check it out and see if it's right. Which means you need to know what 0330 means in real time, what 0530 means in real time, and what 0900 means in real time. So this is a time for you to do some of this practice, okay, with military time, because you do get a lot of questions on military time, because everything is written in military times. The next question for bag B, we have starting time to be 0600, and then the ending time is the run time is 9 hours. So we change 9 hours to military format. We have 0900. So the completion time here is what? 6 plus 9 is 1500. What is 1500 in real time? I leave that up to you. If you don't know it, look it up. Okay, this is how you learn on your own. When you get a chance, go over these slides, go over the questions, and see if you can solve them without looking at mine and see, do you get the same answers? All right, we're on the very last slide, calculating completion time. However, we are going to get a bit more complex this time. But don't be scared because the formula is the same. All right, again, you need your start time in military format, your run time in military format will give you your completion time. However, this is where we can apply the rule of when the answer is greater than 2400, you subtract from 2400. So I just want to give you an example of that. So we have an RN that started IV fluid bag for a patient at 0900 at a rate of 120 ml per hour for 16 hours. Calculate the completion time. Plug in the numbers. Start time plus run time. Remember, 16 hours is our real language, real time. So you have to change it to the military format. And it will give you 2500. Now, do we have 2500? No. The time only goes up to 2400. And this is why we must deduct what we have from the unrealistic 2500. And we end up with 0100. So let's see if it makes sense. What is this saying? If I start running an IV at 0900 and it ran for 16 hours, all right, I'm going to finish sometime at 0100. So if 0900 is in the morning, 9 o'clock a.m., assuming I'm working 12 hours, after 12 hours, I'm going to go home. So by 9 p.m. is going to be only 12 hours from that 16 hours. All right, I'm going to still have about 4 hours remaining to complete this infusion. So in 12 hours, 9 p.m., this infusion is not going to finish. So additional 4 hours is going to now go into 1 o'clock a.m. for the infusion to finish running. So take your time, go through it, compare it with a real-time chart, and see if it makes sense to you. If it makes sense to you, that is key. If it does not make sense to you, it's okay. It only means probably you need more time. Go back to the slides from the beginning, one at a time, and have your own pace of study. The more practice you do with these practice questions, the better you prepare yourself. All right, again, like I said, there are so many practice questions out there online, and once you learn these formulas, go out there and print some questions and challenge yourself. Some of them do come with their answer, the answer key, so you get to test yourself and check the answers and to see how well you're doing. All right, I wish you all the very best. Thank you.